computer. Okay, so as I said, we are today covering chapter 4, and chapter 4 is all about something we call branching. And the idea of branching is very simple. Regularly, a program executes in a form where every single instruction is going to be executed, and after the execution of an instruction, it goes to the next line and execute the next line, and it goes to the third line, execute the third line, and so on. That's what we call the normal flow of execution. And the idea again here is very simple. You execute one line, you go to the next, to the third, to the fourth. And the reason why we use that format specifically, because those instructions are stored inside the memory in memory locations next to each other. And when the processor need to process or execute the program itself, those instructions are going to be fetched from the memory to the CPU one by one. And the most important part is to know the address of the first instruction in the memory, and then after that you're just going to keep adding one to the address, so you go to the next address, keep adding one to the address, so you go to the next one, and so on. This is again what we call the normal flow of execution. Branching is when you start jumping between lines, like you don't go with the normal flow executions, you start skipping some lines of code, or you start repeating lines of code. And that's what we mean by branching. So whenever you start skipping lines of code, this is where your computer can make decisions. And the idea here is very simple, is that what are you going to do? You're simply going to have an expression, or you're going to have a condition, and you're going to test that condition. And based on the results of that condition, you are going to make a call. Should I execute this group of lines of code, or should I execute this group of lines of code? This is how artificial intelligence made. This is how complicated programs are made. This is how face detection and face recognition makes. Any sort of application that include any level of artificial intelligence is simply based on this concept that I'm explaining right now. So we have, again, a branch of a branching. It's called selection structure. And selection structure is simply when you get in a specific line of code where you're going to perform, your program is going to perform a certain test. And then based on the result of that test, the program is going to choose to execute 2 or 3 or different groups of blocks of code, depending on the results of that condition that we just talked about. Repeating structures is simply when you're going to ask the program, or the program is simply trying to repeat a few lines multiple times. And now repeating a few lines for multiple times is very, very useful when we have some sort of scientific calculations, when you have a huge and big data sets, and you need to process the data set, and you need to go over and over these data elements. So this is where what we call the repeating structure is simply used for that case. So let's just leave me talking on the side, and let's just go straight to Eclipse. Where's share? Here we go. And what I'm going to do, I am going to take all this out. We covered all this last class. And before I continue, let me see, does anybody here? Uh-oh, did I? No. Let me stop sharing. I just want to make sure that, are these like loops? Yes, exactly. Loops, that's another name for repeating structures. And for the selection structures, we're talking about if statements and selection and switch statement if statement and nested if statements and switch statements. Now, if you're coming here from a background of Python, Python doesn't have the switch statement, so this might be new for you. Okay, so let's go back here and share my screen again. CSS. Let's just take this project. And we'll just say here, demo for chapter 4. And I don't need the scanner, so I'll just take that out. And here we go. So before I start jumping into how do we implement those selection structures and repeating structures, I just want to stop at a very, very basic concept in programming. For example, if I said integer x, and then if I come here and say x equal, let's say 12 multiplied by 10, this statement here by itself, it's an expression. And this is an assignment expression where we have assignment statement. We have two sides separated with the assignment operator. How the compiler will simply evaluate this expression is simply by evaluating the right side of the expression, and whatever the result is going to be assigned to the left side. Now, this here is what we call an arithmetic expression, and we talked about arithmetic operations last class with multiplication, division, modules, dividing, all these operations that we covered last class. Today, we're going to talk about a very, very special type of expressions. It's called the Boolean expressions. And the Boolean expressions relies on using what we call comparison operators. And it's very important to understand those comparison operators and learn how do you use them. And it's also important to understand whenever you have a mix between arithmetic operations and comparison operations, which operations need to be evaluated first. So this is, again, something we're going to be covering today as well. So to summarize what I just talked about before, I said programming are usually executed using what we call the normal flow. Normal flow is when you execute one line at a time and you move from one line to the other, to the other, to the other. A branching is when you have the choice to repeat few lines for multiple times or to make a decision to skip some lines and execute other lines. The first case, which is the repeating lines, some references will call them loops, some other will call them a more broad name is it's called repeating structure. And for the selection structures, we're simply talking about the if statement, nested if statements, and the switch statement. Now, all of these branches that I just described basically relies on what we call the Boolean expressions. And Boolean expressions, they could be a very simple one, and they could be a very, very complicated one. And we're just going to go through them and try to understand how do they work. So the first thing we should know is the Boolean expressions, sorry, the comparison operations for Boolean expressions. Number one, let's just put them here. We have the double equal. We have the not equal. We have greater than or equal. We have less than or equal. And we have greater than, and we have less than. So those are the basic comparison operators that we are going to use. One thing you have to pay attention here, you don't want to make a mistake. Sometimes this could happen, and this is where you have to double check all the time. You may end up using a double equal knowing that you want to use a single equal, or sometimes you want to use the single equal, but you end up using a double equal. So it's very important to understand the difference between them. And here's what's the difference between them. When you say x equal 10, this is you assigning 10 to x. Okay, but when you say x double equal 10, you're asking a question, does x equal 10? And the answer for those questions is usually one out of two answers. It's true or is it false? So those are the Boolean expressions. Those are the comparison operators. And they're very, very simple, very, very straightforward. So you really, if you have any background with programming, then you should have no problems. Now, we have some limitations when it comes to Java that you have to pay attention to. In Java, you are not allowed to use those operations with strings. Now, you may ask the question, well, how would I use them with the strings? I'll tell you one thing. You're not allowed to say, for example, if I have a string, let's call it name 1, and, string, another string, let's call this one name 2, and let me just come here and I'll say equal. Let's say I'll call this one Adam, and I think I mentioned that last class, and this one is Adam as well. You're not allowed to compare those two names using the double equal assignment. And the reason that you cannot do that, because since both of those are reference data types, so when you compare two reference data types using the double equal sign simple, you're simply asking the questions, are those two referencing the same spot inside the memory or not? So that's why you're not allowed to use it with strings. Another important concept when it comes to the comparison operators, and this is going to be a little bit confusing, and we have to do a lot of work to get over this problem. You're not allowed also to use those operations, specifically the equal one, with doubles. Like, for example, if I come here and say double x1 and double x2, if I come here and say 12 point, sorry, let's just put something like this. If I come here and say x2 equal 12 point, okay? And just to make it a little bit confusing, I'm just going to come here and put 4, 3, 2, 2, 2, something like that. What I'm saying here is that you're not allowed to compare x1 equal x2 like that. Even though if you try to do it, and I'm just going to come here and say system.out.print line. Let me put a semicolon here. Let's just give it a try. And it's showing me false. And we know it's false because, again, after all, this is a 3 and this is 2. So the question that you may ask right now, why is this not acceptable in Java in general? The idea here that my computer here decided to give me this number as false, but you cannot guarantee that with your computer. Your computer may see it as true. The issue that we have here with decimal points, it's because of the precision of these numbers, and we have a lot of memory spaces. So to store at the exact same two numbers in the memory, chances that they may not be the same. And let me just change this one to 3. Now I'm not sure if it's gonna give me true or false, but let me just give it a try. And it is true. Okay, that's a good luck. But here's the deal. This number, as you can see it here, but in reality in the memory is not stored this way. It could be stored as something like this. And this one, for example, could be stored inside the memory like this. Okay, so this small difference here that you see here, and you have nothing to do with it because you decided that this is the value you want to assign to x1 and this is the value you want to assign to x2. But inside the memory, there might be a very, very small portion of these two numbers that may not be exactly the same. And that's why when you compare them using the double equal, you cannot guarantee if the result is going to be the same from one computer to the other. And you cannot guarantee that the result is going to be the same from running the same program on your computer in different times. And for that reason, we usually use those operations to compare the integers and to compare characters. And it's kind of acceptable to compare doubles using the greater than and the less than, but we should always avoid those equal portions. So not equal is not recommended, equal is not recommended, greater or equal, less than or equal, because you cannot guarantee the equality between two double points. So the question that you may ask, well, how do I fix this problem? The idea here has to go through multiple steps, and let me just show you those steps. Number one, I need to give myself a threshold that is acceptable. So simply what I can do, I can say here, if I take, and I'm going to do this, and we're going to talk about this in the future, math.abs, and I'm going to come here and subtract x1 from x2. Let me put a semicolon here. What I just did here, math is a library and it contains a lot of math operations, and ABS is the absolute value. So what am I doing here? I'm subtracting these two numbers from each other. And I want to see, let me see here. Does the length of the number decimal point have an effect on how accurate it is? Well, 2.5 will be more accurate than, well, it's not more accurate. Again, it's something that you don't have control over it. Because no matter what value you're trying to store in a decimal point, there might be a little tiny piece of it that is going to be added to it because of the length of it. So that's the issue that we have with the decimal points. Let me put the comments here so I can see them. Okay, so what I'm doing here, I'm simply asking myself this question. I'm going to subtract x1 from x2. I'm taking the abstract value, and I'm saying if the difference between them is less than 0, 0, 0, 0, 0, 0, 1. That's my acceptable range. So if I subtract those two values from each other, and the value difference between them is actually very, very small, less than this number, then I can consider them as equal. And that's how we usually compare decimal points. So instead of using, let me just copy this. I will cut it, and I'll put it here. Oh, sorry. So this is how we test equality for two double values. You simply subtract them from each other, and you take the absolute value, and you check if that absolute value is actually less than a threshold value that you consider as an acceptable. And if you run this one, I think we might get a true value here, and it is true. Because basically, based on what I'm saying, 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 5, 6, 7, 8. Until this value, they are the same. So it's simply I'm ignoring everything that comes after this value. That way, you can guarantee that you're testing for equality between two decimal points. The bottom line here, what you need to understand is, and I'm going to be looking at this when it comes to grading, try to avoid using those 4 operations when it comes to comparing double values. You can do that with integers, you can do that with characters, you can do that with bytes and shorts, and even long is not recommended to, long is supposed to be treated just like as doubles somehow. Okay, so this is the comparison operations. This is how they work. As I said, this one is used for tests for equality, test for not equality, test if a value is greater or equal, test if a value is less than or equal, and test for a value is greater, and test for a value if it's less. Now, after we learned about those statements, how can we use them to create what we call a selection structure? Now, selection structures, as I said, they come in many forms. The basic form is using the if statement. So where I can come here, I can say integer age, and let's set age to, let's say, 15. Now I want to create a program, a very simple one, to test if that person, for example, can vote. So I'll say if, and look what I'm going to do. Look at this. I'll start with if, and you put a parentheses. After that, you come here and say if age is greater or equal 18, you open a curly brace and you close it, and you type whatever you want him to do. You want the program to do. So I'm going to come here and say system.out.print line. And in this area here, I will just say you can vote. Put semicolon. And then I'll just come here. Not here, sorry. Come on. And I'll put another print line and just say the end. The end. Okay, so here we go. This is my program. It's a very, very simple program. We have a variable called age. I'm assigning a value to the age, and I'm simply checking if age is greater or equal 18. If this condition is true, that person is actually that age variable is actually greater or equal to 18, then this line statement is going to be executed. Otherwise, this whole block is going to be skipped, and you're going to come and execute this line. And if I run it, that's basically what I'm going to get. The end. Why? Because this condition here is false, so it will not work. Let's just come here and put this as 19. And now if I run it, it will work. It says you can vote, the end. That's a very simple if statement. Now here's some facts that we should know about this statement. Number one, never put a semicolon here. Never. This semicolon, if you put it here, and I see a lot of students do that, this simply means you're telling me that this is the end of the if statement and this is just a normal part of the program. So let me just show you what's going to be the result if I do it that way. You can vote. Let's put this as 10. And you can vote. So never put a semicolon here. Another thing you have to pay attention to is that if your statement here, if your block of this if statement is a single line of code, feel free to take those parentheses away. That's acceptable. But the moment you have multiple lines, then only at that time you have to surround those lines that you want them to be executed when the condition is true between those curly braces. Now, this program by itself, if you look at it, well, yeah, if he can vote, you will see the message you can vote. But if he can vote, you will not see a message to tell him that you can vote. So how do we fix this problem? Well, this is, again, a very simple if statement. We have something called if-else statement. And if-else statement, you're simply asking the question, you're evaluating this expression here, and you're telling the program is simply having two choices. Choice number one, if the condition here is true, you run this line. If it's false, you run whatever you're going to have here. So let's just put a statement here. Copy, and let's put it here, Control V. And you'll say you can't not vote. And now if I run it, since it's 19, so he can vote. And if I come here and change this one to be, sorry, this is not supposed to be 19. Okay, so let me just run it. Since he's 19, so he can vote. If I come here and change his age to be 12, you'll see that I'll give the message. You can vote. Okay, so this is a very simple if statement, and then we have an if-else statement. What else we can have? Let me just give you an example here that will make more sense, a little bit better than this example here. I'm going to come here and say integer working hours. Of course, we cannot use a space. So working hours. Let's set the working hours to be 67. Now, what we want to do, we want to create a program to calculate the payment for a worker for a whole week based on the hours he worked. Now, he's a full-time worker, so he's supposed to work 10 hours a week. Sorry, 40 hours a week. And if he worked 40 hours a week or less, then he will get a regular pay rate. The moment he passes the regular hours, then the extra hours are going to have an extra rate. So our job is to find his total payment. So I'm going to come here and create a double. And I'll say total payment. This is a value that we don't know. How much is it? So we'll keep it that way. We need to know rates. So I'm going to come here and create an integer. Let's put a double. Sorry. Final double. And we'll call it. We're going to call it the regular rate. And the regular rate, we'll say he's going to get paid 12 hours and 50 cents. That's the regular rate. Let's copy this and create the extra rate. Command V. And with the extra underscore hours rate. Let's say he will get paid $15. So those are the rates. Now he's working 67-hour, and this is basically what I need for now. So here's what we're going to do. We're going to come here, instead of looking at the age, we don't have age anymore. We're going to look at the working hours. Let's go ahead and put working hours. Now, if the working hours was less or equal 40, he could be working less than 40 hours. Then I'm going to be doing calculations here. Let's take that out. And if he's working more, we'll be doing calculations here. And then after that, we'll show the result on the screen. So let's look at the calculation. Well, if he's working 40 hours or less, then we're just simply going to say the total payment is going to equal the working hours that he actually worked multiplied by the regular rate. And that would tell me how much we should pay him. If that's not the case, if he worked more, well, my payment in this case is going to be break down into two payments. The first one is that he's going to get paid for the first 40 hours, and the other one is going to be for the extra hours. So what I need to do here before I continue, I need to create another final. This time it's going to be an integer, and we're going to call it regular hours. Regular hours, he needs to work 40 hours a week. So if he worked more than 40 hours, then I have to pay him for the first 40 hours with the regular rate. And then after that, I'm going to pay him for the extra hours. Let me put a parenthesis here, multiplied by the extra hours rate. And now the question is, how do I figure out how many hours did he work extra? Well, in this case, for example, we're saying that he works 67. So the idea here is that if you take those working hours and you subtract them, if you subtract the regular hours, which is the 40, and you subtract it from the hours that he actually worked, that will give you the extra hours that he actually did. And based on that, you're going to have two payments here, one for the regular hours and one for the extra hours. And then after that, we have the total payment calculated. You can come here and just show it on the screen. Let me copy that. Command V. And then we just say your payment for this week is, and you come here and put a plus. And where is it? Here, total payment. Now, of course, if I want it to look better, I will just come here and put, let me put a $sign here. And let's just give this a try. Your total payment is $905. Let's change this one to be, let's say, 40. And he has 5,000. So this is again how of course, now if you want to make sure that this program is working correctly, you need to have a calculator and check it out. But since I want to check the program, and this is something new we didn't mention before, I can debug the program and see how the execution is going. Now, I want you to pay attention to how do we do that. You double click at the beginning of the program until you get the circle here, and you double click on the end of the program to get a circle here. And then at the top here, you click on the bug here. When you click on the bug, he's going to tell you a message. Do you want to switch? Of course, I want to switch. And now a new layout is going to show. And the line that's executed is going to be shown here with the highlight. And this side here to the right is showing you the variables. So what you need to do, you need to click on those arrows here, those arrows here. I'll just click on step over, okay? You don't have to go step into. Step into will simply take you to other files, which I don't want to do that right now. So step over, click on it. The execution is going to move for some reason, yeah, he skipped the second line because there's no assignment operator there. But it's telling me here that the working hours is 40. And then he's telling me that the regular rate is 12.5. And then the extra rate is rate is 15. And now he's telling me the regular rates hours is 40. And now here's the thing. This is the if statement. Now, when I'm going to click step over, he's going to go and execute one of those two lines. So he decided because it's 40, he's going to execute this line. And if I click step over, he's going to skip the else statement. He's going to get this, but he's going to skip it. And now it's showing me the total payment here is 500. And after, if I continue that way, the end, and that's it. Now, if I want to go back, I have to click on the arrow here. That will get me back to my original program. And then after that, of course, I can terminate the execution here to end up. Now, if we want to run it regularly, you can do that. This way, it's going to work. But if you want to see the step-by-step execution for each instruction, you click on the debug main class. Let's change this one to be 45, just to show you how it would work. You want to switch? Yes, I do want to switch. And now if I go step over, step over, step over, step over. Now, this condition is false at this time. So simply, it's going to skip it and it's going to go straight to the else. And then it's going to show it on the screen, show it on the screen. Let's go back and let's close that. Let me take those two dots away. And this is how the if-else statement works. Now, we do have something called the nested if statement, and the nested if statement works in a different way. Nested if statement is like this case that I'm showing you here. It relies on a very simple situation. Did you work extra hours or you didn't work extra hours? So the answer here is yes or no, true or false. But sometimes we need to make action based on questions that are not as simple as yes or no. For example, now in Florida, there's a hurricane hitting the state. There is a software, of course, that will simply check the speed of the wind for this hurricane. And based on the measured speed, the hurricane is going to be classified. And based on the classification, the action that's going to be taken by the state will vary. So how can we do something like that? I'm just going to give you something a lot more simpler than that. What if I have a grade? Let's go ahead and put it here. Integer, a grade. And this grade, for example, is 76. And I want to create a program that will convert this grade into a character. So I'm going to come here and create a character, and I'll say grade CH. Of course, I don't know, 76, is it an A, is it a B, is it a C, is it a D? I don't know. So let's create a program to get the job done. Here's how it works. Number one, I'm going to assume, well, I'm not going to assume, but let's start with this. If I come here and say if statement, and I'll start with this. If the grade was greater or equal 90, that simply means that grade CH is A. And that is correct somehow. Yes, if you have grade that's greater or equal 90, then you got an A. But the problem with this technique here, what if we decided that the grade is going to be 176 by mistake? So we need to take that under consideration. But for now, I'm just going to assume that there no such an error. Whoever's going to enter the grade is going to be within the range of a 0 and 100. So here's what I'm going to do. I'm going to come here and say if, sorry, not if. So this is the first case we covered, if the grade was 90. Now, you may think, and I'm going to do it here for the sake of it, if, and you know what, there's no need for me to type it. Let me just copy this. Control V, Control V, Control V, Control V. So I'm going to come here and say, if the grade is 80, that's a B. And if it's 70, A, B, C. And if it's 60, that's a D. And if it's If it's 60, that's a D. If it's anything less than 60, that's an F. Okay, so this is me checking for all the possible grades that we can have, assuming that we will not have anything less than 0 and anything that's not greater than 100. So what am I doing here? I'm simply comparing the grade with 90. If it's greater than 90, then that's an A. But here's what's going to happen in this program that you see here. He is going to decide that the grade is A, and he's going to continue comparing it with 80, comparing it with 70, comparing it with 60, and comparing it with 60 again. So even though, let's just put it here, if the grade was 96, even though that I was able to figure out what is the grade character at the first if statement, but my computer is simply going to go with the rest of them. So how do we fix this issue? Very simple. We will just type if, so we'll type else if. And to make it look a little bit better, we'll put it this way. And I'll tell you what's the difference between this one and the previous one. So let's go back. And another else, if. Now, of course, this one, I really don't need to put an if statement. I'm just going to put an else. There's no need for the last if statement. Because if a grade is not an A, and it's not a B, and it's not a C, and it's not a D, then by default, it should be an F. Here's the difference between what you're seeing here and what I did before. What I did before, I said, it's just going to keep going with the checking process. Even you decided that the grade here is 96, so that's supposed to be an A. But previously, you had to complete the check for the B and for the C and for the D and for the F. In this case, there's no need for that. The moment you get the first statement to be true, everything behind or after that if statement that was true is going to be ignored. So you're saving your computer program from executing all these if statements, which again, that's going to be interpreted as better performance. Of course, let's say the grade was 86 in this case. Well, if it's 86, this is going to be false, so it's not going to be executed, but then it's going to come here, and this is going to be true, so this is going to be executed, and everything else is simply going to be ignored. So this is what we mean by an if-else statement. If-else statement has one of the main disadvantages that it's a little bit complicated, so it's kind of hard to trace the execution and what's going on. Especially when it gets bigger and bigger and bigger, it gets really complicated. And believe it or not, sometimes you end up having an if-else statement for this one by itself. So that's why if you can avoid using nested if statements, that would be a good thing, but it's really hard to do that. We have another technique that we're going to talk about later that is way, way better and easier than the nested if statement. And every time you find yourself in a position, if you can go with the other technique, just go for it, because it's going to be a lot easier and a lot simpler to follow. Now, the only thing that I want to add here, I just want to have a case where if the user made a mistake, it should not be accepted. So here's what I'm going to do. And actually, no, I'm not going to do it right now. I'm going to keep this, and then later I'm going to cut back to it to fix this issue. My idea here is that what if the grade was 112 or 23, or the grade was negative 89. If you have any of those two cases, well, simply if you have 123, that's an A. Negative 89, that's an F. This should not be acceptable. So later I'm going to talk about how do we fix a case like this, of course, but let's just keep going because we need extra tools to be able to handle the situation. Okay. Okay, I'm by the way, just looking at the PowerPoint to make sure that I am not missing anything. There's a program in the PowerPoint, I highly recommend to have a look at it. It's an example. It's simply asking you to write a program to ask the user to enter a sentence, and then the program should enter and print an error if the user didn't print a period at the end of the program. I feel like this is a good example. The code has been given to you, so I don't want to spend the time here going through it. I want you to go have a look at it. It's very simple, it's very easy, and it's very, very good to follow. Now, just like how we have those comparison operations, we also have another list of operations. We call them the logical operations. And the logical operations, we have mainly three logical operations: and, or, and not. So what are these logical operators? Those logical operators are simply operations we can use to merge and create complicated Boolean expressions. And it's very, very important to understand the functionality of each one of them. After I'm done, I'm going to show you how do I use those to improve the performance of this program. So let's go one by one. The or, the and operation. And operation, it's a logical operation, let's just put it that way, where you will have two sides that are going to be separated with the and operator. If both sides are true, then the final evaluation for the expression is going to be true. Otherwise, it's going to be false. So what is that supposed to mean? Let's just go ahead and do this. I'm going to come here and say system.out.print line. And I'm going to come here and say 10 double equal 10, which is true. And then I'm going to put and 10 is greater than 5. Put it here. Now, this is a Boolean expression. Again, it doesn't make any sense for now, but just go with me. And this is another Boolean. You know what? Let's just go with using the grade. So that will make it easier to grade. So I'm just going to say if grade does equal, do I have any other variables here? Working hours. Even though that doesn't make any sense. No, I don't want to do that. If the grade does equal, well, this is not going to work. Yeah, let's just write that 86. At the same time, grade is greater than 50. This is, again, a Boolean expression, a little bit complicated Boolean expression. We have two sides. We have the left side here, and we have the right side here. For this whole expression to be evaluated as true, both Boolean expressions need to be true. And if I run it, it's simply going to show me that is true. Now, if one of them changed to be not true, so for example, if I put this one, so it's going to be false, then despite what you have in the other side, it's going to be false. Now, let's just copy this and go down. And let's see, how does the or work? Well, the or work in a different way. Or will be true as long as one of those two operations, Boolean expressions is true. So if this one is true, or this one is true, or both of them are true, then you get true. The only case you will get a false if both of them are false. In this case, since this is false, but this is true, then it will work with no problems. So you get the true expressions. Okay, true results. Now, this is very, very critical because the questions that you're going to be giving and the projects you're going to be working on, they're simply going to be the tools, or your choice of those operations relies on how do you understand the project that you're working on and how do you understand the problem that you're trying to solve. This, again, will be reflected, your understanding for that project will be reflected on your choices and to making the right choices when it comes to creating Boolean expressions with logical operators. Before I continue, we should know one thing, very, very important thing here. We have something called a short circuit. And the short circuit is very, very critical and very, very important. And I remember in one interview that I had a long time ago, I was asked a question about the short circuit, even though I knew it, but it was very, very tricky. And it just popped out of my head and I didn't answer the question correctly. So I just want to bring your attention to this. Short circuit is simply when you have a regular Boolean expression that contains those logical operators. The idea here is very simple. If you have an AND operator separating two Boolean expressions, if the first Boolean expressions to the left was false, it doesn't matter what you have at the right side, because the whole expression is going to be evaluated as false. So the computer will simply skip executing this line, and the whole expression is going to be false. Okay, that's for the OR, the AND operator. Now, for the OR operator, if the first expression is true, it really doesn't matter what's going on in the second expression, and it's just going to ignore it and not execute it. So as long as the first one is true and you're using a Boolean expression, or the second side of the expression is going to be ignored. And if you're using an AND operator and the first Boolean expression is false, this is going to be ignored. And let me show you the question that I was asked in the question in the exam, in that interview. And the question was very simple. Let me just say J, integer J equal 10. And then they said, for example, we'll use the grade again. So I'm going to copy this here. Put it here. And the question was J plus plus is greater than 10. And they asked me, what is the value of J? Now, me at that time, I totally forgot about the short circuit. So I told him J will equal 11. Why? Because this expression here, I'm increasing the value of J. Okay, so J is going to equal 11. And then after that, the whole evaluation for the expression is going to be false. But J will have the value of 11. And then it turns out that J is actually not 11. Because this is false, the compiler will ignore this portion of the program. So it's not going to execute it. So J will simply hold the value of 10. So this fact here is what we call the short circuits in computer programming. So it's a good idea to pay attention to those small details. Now, the last operator here that I chose not to talk about it till this point is the NOT operator. The NOT operator is one of those operations that you should try to avoid as much as possible, because having them in expressions will simply just make the expression a little bit more complicated. So if you can avoid having it, that would be a good idea. And let me just show you what do we mean by that. This expression here that you have here, work hours is 40. What I can do, this statement that you see here is simply going to process the case of if it's less than 40, and this is for if it's greater than 40. Here's what I can do. I can come here and type not. And by doing that, I'm simply flipping the situation here. So instead of working hours less than 40, if that's true, the final evaluation is going to be false. And because it's false, then I have to put this statement here and put this one here. Okay? So the reason why I'm saying try to avoid using it as much as possible, because again, it's just going to make understanding your code a little bit complicated. I'll give you an example. And instead of asking, for example, a person about their, let's say, trying to use something here. If you are a baby, you'll do this. And if you're not a baby, you'll do that. And instead of that, I will start with, if you're not a baby, do this. Again, avoid using the not. Go with, if you're a baby, we'll do this. If you're not a baby, as the else statement, we'll do something else. But again, the idea here is that you have that tool available, but try to avoid using it as much as possible. For example, in medical image processing, if this region is cancer, do this, else do something else. Or I can say, if this region is not cancer, sorry. Why do I have to go that way? Just say, if it's cancer, do something. If it's not cancer, do something else. Instead of starting with the not. And again, when it comes to the executions, this has nothing to do. It's just going to work normal with no problems. But again, having the not will simply lead sometimes to some confusion. So that's why we say try to avoid it as much as possible. Now, let's go back to our program here. And let's see how can we actually use, let's see here. I'm just want to try to sure that I'm not missing anything here. Let's go here. How can I make sure that the user will not enter values are invalid? For example, something that's greater than 100 or something that's less than 0. So here's what we're going to do. I'm going to come here and I'm going to update this situation, and I will say if the grade was less or equal 100 and the grade was greater or equal 90. What I'm doing here, I'm checking the range. If that value is 100 or less, and at the same time, it's greater than 90. So simply I'm asking about all the grades between 90, 91, 2, 3, 4, 5, all the way to 100. If that's the case, yeah, it's going to be an A. Let's come here. I'm going to come here and put an if statement. And for this if statement, I'm going to put the following. If the grade was greater or equal 0, and the grade was less than 60. So simply in this case, I'm including the range from 0 all the way to 60, not including 60, because 60 is a D. So it's going to go all the way to 59. You can put it this way, or you can put it less or equal 59, but I think it's going to be 59. It's whatever you feel more comfortable with. So this is the case. Now, I still have an else statement here, which is, what if the user decided to enter a negative value or a greater value that's greater than 100? Then all I have to do here is just come and print an error message. Invalid entry. Of course, after that, I might want to actually show what is the grade. I will come here and put, now he's going to complain about this line because he said, well, there is a possibility that this grade will not have a value, because again, for this if statements, the grade CH will have a value as long as those conditions are true, but there's a possibility for this expression to be executed. So if this is where I have to give it a default value, and I'll just go with nothing. It's extra space. Or N as an indication for none. So if I run it, you'll see that the grade is in this case B, but if I come here and put 100, there's going to be, oh, how is that possible? How is that possible? Let's see. Grade. Oh, look at this. Look at this. Okay. I have to go and update the whole thing, because right now at this point, I'm saying if the grade is less than 100 and greater than 90, of course, this is not going to be true because the grade was actually greater than 100. But when it's going to come to the second one, it's going to compare the grade to the 80. And yes, 180 is actually less than that. So I have to come here and update this as following. Oh, I thought that I'm done with this. If grade is actually less than 90 and the grade is greater than 80, and I have to do the same thing here for the C. I have to come here and put and I'll put 80 here. And I have to do something for the 60. And we'll just put 70 here. And then 60, and if it's greater than, yep. So this should work. Let's give this a try again. And now it's in. And I'll have an invalid entry. So these are, again, the Boolean expressions using logical operators, using comparison operators. It's very important to understand the priority of those operations when you mix and match between them, which is going to be covered in a sec. But let me just go through. Sometimes you may have a program where you ask the user if you want to continue with something. So you will wait for the user to enter something, and that user may end up, for example, the answer that you're expecting from the user to be yes. But that yes could be a lowercase yes, uppercase yes, all uppercase yes. So it's very important to have a mechanism of checking all these possibilities. We know that we have a tool called ignore the case. That's what we use usually. But sometimes the answer could have multiple words. So you need to have a condition for each one of those multiple words. So let me just continue. I want to see if we are doing good here. The not operator, covered that. The switch structure. Today, by the way, we're just going to cover the selection structures. And next class, we're going to talk about the repeating structures. I'm double checking with the chat. Okay, everybody's doing good. Now, what is the switch statement? Well, the switch statement simply came to fix this problem, to try to avoid using those nested if statements. But here's the deal. Sometimes you have no choices. You have to go with a nested if statement. Sometimes you do have choices. Okay, so let's have an example here about a case where I can use this just switch statement. And after that, I will show you that this example specifically, I can put it in a switch statement, but it's going to be way more complicated than this nested if statement. But I'm going to show you both cases. Now, just imagine we want to create a program that will convert the months from numbers to be printed in a form of 3 characters. For example, March is going to be MAR. September, SEM, September, SEP, and so on. So I want to create a program that will do that for me. I want to convert the number to a string. So how do I do that? So I could come here and say integer month, and I'll set month, for example, to 4. And here's how the switch statement works. Very, very important because the structure is a little bit complicated. You start with the keyword switch. And as you can see here, the color immediately changed. You open your parenthesis and you close it. And you open a curly brace and you close it. So this is the beginning of it. Here you put your expression. And in your expression, usually it's a variable. And in this case, the variable that I'm using is month. Now, before I continue, let me tell you what type of variables you can put here. Before Java version 7, you are only allowed to use bytes, shorts, integers, and characters. After Java 6 and starting from Java 7, you can actually include strings here. So when I was learning Java a long time ago, strings were not acceptable. Recently, strings started to be acceptable. They changed that. And again, having strings here, believe me, it will make the job a lot easier. So what am I going to do? Here's what we're going to do. How many cases do we have in months? How many months do we have? We simply have 12 months. So what are we going to do? We're going to have to go and create cases. We're going to say case 1, case 2. This is for January. This is for February. Case 3. And notice how I'm writing the double, the colon. Let's go ahead and put them all, and then I'm going to change it. So we got case 4, case 5, case 6, case 7, case 8, case 9, case 10, case 11, sorry, case 12. And finally, we need to have a very special case called the default. default case, just in case you came here and you entered 14. We know that there's no 14, there's no month that has 14 integer value. So we have a default case just in case there's a mistake. None of those cases actually matches the value that you have here. The idea here is very simple. What's going to happen? The compiler will simply take the month, which is the value of 4, and compare it with all the cases until it finds a match, which is going to be this cases. After a match is found, whatever is underneath the case 4 is going to be executed. So let's go ahead and put what's supposed to be done for each one of those cases. Go back. Case 5, case 6, case 7, case 8, 9, 10, 11, 12, and then the default case. The idea here is very simple. All I'm going to do is print a message. Let me copy the print, convert, and then let's open a parenthesis and put semicolon here, and I'll put double quotation here. And I'm going to copy this, repeat it everywhere, and then after that, I'm going to update each one of them. Come on. Control V, V, Control V, Control V. By the way, you can type it next to it, but for improving of the readability of your code, put them in the format that you see here. And I'll just say here, this is the easiest one, invalid entry. You made a mistake. It cannot go out of those choices. Now, here's what we do. For example, this is January, Jan, Feb, MAR, March. I'm on March. APR, June. June, July, August, and September, October, November. Did I miss something? January, February, March, April, May. My bad. May, June, July, August, September, October, November. I'm almost done. October, November, and December. But I'm not done 100%. Now, this is missing a very, very important command, which is break. So you need to have a break for each case. I'm going to copy this and put a break here. Break. So break. So break. So break. And break, break, and break. God, break. Too much break is. And finally, a break. Now, of course, you can add a break here, but again, that will have no effect, so you really don't need to put it there. So this is what we mean by switch statement. This is how it looks like. Now, I want you to, just to give you an idea, this program that I had at the beginning, I have case situation here, and I'm testing the situation. If the final evaluation is true, I'm going to be executing this line. If it's false, I'm going to executing this line. Now, with a switch statement, we simply don't have an expression that is true or false. We have a variable, and we need to make this. We need to take actions based on the value of that variable. And the idea here with the switch is simply is going to compare a month with each one of those cases, look for a match, and whenever the match is found, whatever you ask him to do in this case, he's going to do it, and then break simply would take them out of the switch statement. Now, this is supposed to print the value of April. So let's give it a try. At the very bottom, I got April. Of course, if I put something that is not acceptable, I will get invalid entry. Okay. So the last part I want to talk about here is when should I use switch statement and when should I use a nested if statement? And I'm going to show you that I can convert this to an if else statement, but with a switch statement looks really, really better the way you see it here. But instead, I'm going to show you how do I convert this statement here, this program, into a nested, into a switch, this nested statement. So here's what I'm going to do. I'm going to come here and do the following. You know what? Let me just do it at the top. I'm going to come here and say switch, and I'll put a grade. And I'll put a parenthesis and close it. Okay. Now we will have cases. So let's say with case, and I'm going to put semicolon here, and I'm going to jump into the default.
I have a question.
Yes, go ahead.
Couldn't you put like an if statement and then do like is in that if statement if it's greater than 100 or less than 0, and then if it is, then have it like spit out something?
Which part are you talking about?
Let me rephrase this. So, like, can you put an if statement inside the if statement?
Oh,
And then
inside of the statement?
yeah. So like you have the if
Uh,
statement, then you put an if statement inside that. And then if it's greater than 100 or less than 0, it'll just ignore the if statement inside the if statement.
Okay, let me see. What do you mean by that? It's I'm finding a little bit like let me just are you talking about this example here?
No. I'm talking about like if let's say you have an if statement and then you have an if statement inside that one.
So
Like
let's
you
just
can
give an example here. If, and then you have an if statement here.
no. Like inside the brackets.
Yeah, here. You mean here?
No,
Oh, I see what you're talking about. Like an if statement here,
yeah,
and an if statement here.
yeah.
Yeah, that's a possibility.
And then if grade couldn't like
Yeah,
grades are over 100 less
you
than
can
0.
have two choices here, like this or else.
Yeah.
That's totally normal.
Okay.
Yes, that's acceptable. It's more like I'll give you an example. You mainly have two main cases. Case number, if this one is true, and then if it's not true, you're going to go to the else case here. And this else case, you can have an if statement here, and you can have an else statement here as well. But it's a matter of thinking about when I'm going to have a case like that. I will give you like the scenario that I can think about right now. If you have one big problem, and you want to take an action for it in a case like this, and if it's not true, you take this action. And you know what? I think I can have. I'll show you an example about this right now. But before I get to this point, let me just go through this example so I don't forget. So we have a default case here, and the default case is simply going to print this invalid entry. Now here's why using a switch statement for this range example of grades is not a good idea. Because here's what's going to happen. You can have case 100, case 99, case 98, case 97. Do you see where I'm going with this? Case 96, case 95, case 94, case 93, case 92, case 91, and then finally case 90. If those cases, one of them is true, I will just come here and change the grade to be A. And I have to do the same thing for B. So this is going to be case 89. Let's take this one away. Case 88, case 87, case 86, case 85, case 84, 83, 82, 81, and case 80. What's that going to be? That's going to be the grade of B. You see where I'm going with this? This is a case just to show you that switches statements, sometimes it looks cute and pretty and everything, but in some other applications, no, you better go with the nested if statements. And I'll give you just one tip here. If you're talking about range of values, don't think about switch, because switch doesn't have the ability to check for test of values. It goes by value, one by one value. So you cannot use switches for testing range of values. Also, switches, you cannot use double values. You cannot use double values. Okay, now, and H78, I think you mistakenly typed something, Cody. Anyway, so let's see. Let me go here. The last thing I'm going to talk about today. Oh, it's almost time, but I'll just keep this one here. And when we come next week, I will make sure to show you guys an example of how this structure here that I have will work and will be used. So again, every single structure that you're going to use in any project, again, depends on the project itself. Sometimes you can have very, very complicated if statements. Sometimes they're simple. So it totally relies on the project that you're working on. Okay, so it's now 7:15, so I believe this is the end of the class time. If you have any questions, let me know. Otherwise, you guys enjoy the rest of your week and enjoy your weekend.
Thank you.
You're welcome.